There we go. Hi everyone, hopefully this is all coming through clearly for everyone. Let's see if this is all working. Hopefully all looking good. Let me just turn the gain up a bit on the mic. How's that turning out for everyone? Sounding good? Okay. I'm just checking the final few things over here, and before we get started, hopefully everyone can see the stream okay. Cool. Is the video updated? Because it's not updating on my screen. Hang on, let me refresh my web page. Oh, there you go. It's working now. Cool. Right, I'll just close this down. So I'm just setting up my second screen. Okay. Okay, so yes, we are looking at today a Clamber system. So what is a Clamber system? Well, a Clamber system is much like you see in FPS games such as Apex Legends. Halo 5 also had it as well, and that's when you sort of scurry up a wall and climb over it if it's short enough or tall enough for you to actually do so. So this is a live UE4 tutorial. What that means is I will be tackling this problem live in front of all of you. I have not done anything like this before. I have not done any pre-work before this. I've only thought about it in my head. So you're going to see my working out. You're going to see me encounter bugs. You're going to see me fix those bugs. And basically, the whole point of these live videos is to show you my method, my working out method. So you get to see firsthand just how I'm approaching these problems and how I'm solving them. So last week we played Apex Legends on a case study, and looking at the way they could have handled their Clamber system is, I think the way they're doing it is the way if you jump when you're near a wall, it's going to scurry up that wall until a certain distance, and at a distance you'll either fall down. If it detects there's a ledge there, then it'll pull yourself up on that ledge. So got a few things there to figure out. So all I've got at the moment is just a first person template set up here, and I've gone ahead and removed the unnecessary bits like the gun, the VR stuff and all that, because I don't need any of that. No, I'm not worried about the gun or shooting. We're just looking at getting the Clamber working. So for this to work, the aim of this evening is to try and get him to climb up this wall. Okay, we may fail, but hopefully we'll learn a lot along the way. Okay, so let's begin. So the first thing I want to do is detect whether or not I am jumping next to a wall. Okay, so when I push jump, I want to detect whether I'm up against a wall. So if I go to my first person character blueprint, here's all the code that belongs to that thing. Let me just delete this, like that. That was some junk that I left over. So I'm looking for my jump, and here's my jump here. And oh, hello. And we're going to be going from this quite a lot for this video. And the first thing I'll do is going to check whether or not I've got a wall in front of me. So to keep things nice and tidy, I'm going to make a function, and it's going to be check for wall, and we're going to do a very simple line trace in front of us to see if there's a wall there. So line traces are very useful, and they're very cheap to use, so by all means use them. And what it do is basically send an invisible line out from wherever you determine to detect if it hits something. So this line trace bar channel got a start and end point. The start point for this is going to be the player's camera. So I'm going to drag the camera out, and I want to get the direction the camera is facing. And the way you do that is you get the rotation. It's world rotation, and then from there you get the forward vector, and that is your direction. Okay, and that would be my that's for working out the end point. We want to get the start point. Start point is the location of the camera, so we do get to location like so, and that gets us the world coordinates of our camera, and that will go into the start, and the end point will be the direction of the camera, which is this, which we've already done, and we would go only a short distance, so I want to multiply that by a float, and quite a small float. I'm going to check directly in front of me, so I'm going to do a 50, and I'm going to add that now to our starting position, and basically that just tells it to end in front of us by 50 units. So check for wall. It's going to be called this line trace. The trace channel I'm going to change to the camera. The difference between these two is, say you've got a window, for example, visibility trace will go through that window. Okay, so the trace won't detect the window; it will keep going through it. Whereas the camera will block it. I believe that's the way around it is. If not, it's the opposite. But I believe that's the way around. I've got chat up on my second screen here, so I will try and answer questions as I go on. But apologies if I do miss your question. But yes, so if you want to do like wall running and things like that, this is a very similar sort of setup for this as well. Okay, so let me have a look. Oh, let me put this. Hang on. There we go. So you can see the chat on the screen now. Okay, so that's going to get us out hit. But before I do that, I'm going to do a debug for, let's do duration. And I just want to see if this works. Okay, so on my event graph, when I jump, I want to check for wall. So I can just drag check for wall out, like so. Power that, and let's test that out. So if I jump, you can see that line. There's a line trace coming out for it there. So I just need it to be a bit longer because it needs to hit that wall. Okay, so 50 isn't long enough. So let's go back to our function and change that 50 to say 150. And let's test that one out. It's a good idea to test things as you're going. Just every single step, just test it. And there we go, I've got a hit. So that little red square means I hit it. When I jump, I've detected I'm at a wall. No hit. Hit. Cool. Okay, so we've got that bit working just fine. We now want to look at getting we want to continue up the wall. So when we detect wall, we need to continue up the wall. So Avaku, after the stream finishes, will it turn into a video? Yes. So the way it works with live streams, the video on demand will be available to patrons who support me on patreon.com/Ryan Laley. They get access to the video straight away as soon as the stream finishes, and everyone else in the public gets access to the video 2 weeks thereafter. So if you want this video straight away, all you have to do is donate $1 and you'll get it. Okay. Higher levels of the Patreon tiers will get access also to the project files, so they get to see and play around with my code from the stream as well. Okay, so we've got this function, and check for wall. I'm going to have a output for this one, returning true or false. So we're going to be hit wall. That's going to be a boolean, and I'm just going to be returning the return value here. Click compile. We're done there. So that output here is going to come from this function here, and that means I can now use this to determine whether or not I should continue going up the wall. Okay, so the way this is going to work is we need to change the movement component of it, because the movement at the moment will gravity will automatically send the character pawn down. So I'm going to tell it not to listen to gravity for a moment, just let it continue flying upwards. So with this, I need a branch, and after which I need to make it climb. So I'm again making another function for this, just to keep things nice and tidy, called climb. And the climb is going to take the character movement, and we need to change the movement, what they call it, movement type, movement mode, isn't it? Set movement mode, there you go. So climb, set movement mode to flying. Okay, we'll see how this works. So set to flying. That means gravity will no longer push us down. Okay, it means we'll just continue going up if we wanted to. So set climb to that, and then I want it to go up. So how can I make it go up? Movement input. Just reading what the descriptions are. That's given vector to this would work, except for this climb will only be called once as soon as we hit the input action. So what I need to do is when it's being held down. So I need to make a start climb and a stop climb, don't I? Yeah. Or do I? Let's have a think. Okay. Just brainstorming here in my brain a moment. The issue we've got here is this jump action. This event here only will consume input. No, that's not what I want. This will only happen as soon as I hit the jump key. I think it won't continue. Well, actually, let's test this out. We can test it. If I do a print string, I'm pretty sure hold down the jump button, and I still only do it once. No, what's the error? Do that. Let's just test out the theory. Yeah, so it does it once. So that's the problem. I need to make it so whilst I'm holding down the space bar, it continues to climb. So what I need to be able to do is tell it to climb. Okay. Kim North, you can't use delays in functions because what's the term? Functions only they happen inside. Like, think of the way a computer works. A computer works through a list of instructions. One of those instructions will be a function. It cannot. That function happens all in one cycle. So you cannot delay that cycle, or it delays the whole entire game. If you were to delay the function, it would delay everything. So we can't delay that function. Okay, I can't remember what the term is for it now. Mine's going blank, but yeah, so you can't delay functions. But there are ways around it. World direction would be a positive. Yes, the movement part isn't an issue. It's the getting it to do it on the loop. Okay, so I want to do it whilst the key's being held down. So I've got a few ways around this. I can make another event called climbing event. I can change the input asset to be different. So let's just try things out, see what happens. So we're going to go to, let's do an event here. Custom event. Climb. Oh, we can't do this one. Climb wall, I'll call it. Functions and events can't share the same name. So climb wall. Climb wall. So if it's true, climb wall will trigger. And yeah, what we'll do here is we'll add movement input. And I wonder if this will just work without changing the mode, actually. So if I change my Z to be 1, and do event timer. That work? This may break completely. We'll see. So every 0.5 seconds on a loop. Oh yeah, it's broken. Let's ignore that function for now. Let's just see what happens here. Can't tell. So let's put some print strings in to figure it out. So climb wall, do print string. We should get a loop of this print string going. So I'm holding down the key and it's printing the hello. Okay, so that bit's working. It's just not actually doing the movement. And I think that's because the movement mode isn't been changed. So this movement mode, I can just copy and paste over here. Actually, delete that. We'll put that up here. So it's true. Movement mode changed to flying. Compile like so. So I push spacebar. Hey, working. Obviously, I'm flying still. I have to tell it not to fly, but we've got it going up the wall. Hold down spacebar, just continue going up. So I need to tell it to basically turn gravity back on. So now for the stopping part. So if I was to let go of the spacebar, i.e. stop jumping, we need to tell it to stop the climb wall. Okay, so we're going to take the set timer. We're going to promote that to a variable. Climb timer. And when we stop jumping, we are going to set the movement mode back to the walking. And take our climb timer variable and clear and invalidate it. And that'll tell that thing basically to stop looping. Okay, so I'm going to click compile, play, climbing up the wall, let go, drop down. Nice. So I just need to work out to tell it to stop hovering and make sure it only continues whilst I've got something in front of me, because at the moment I can just fly around. So I'm going to disable all other inputs apart from the jump input. Okay, but we've got something there. We've got something there. Obviously, it needs to be a bit faster. We can work that out. Got the direction there, scale value. We can change that speed, I guess. We want to change the speed of the movement. I don't know what kind of movement that would be. Would that be walking movement? No, it'd be flying, wouldn't it? Jumping, falling, walking, flying, max fly speed 600. That's quite fast. It should be faster than that. Why can't I? So if I'm over here, so my movement speed horizontally is a lot faster than it is in the vertical. So I wonder why that is. Okay. Let's have a look. See. Hang on, just checking something here. Okay. Yeah. So, what movement controls that? Vertical speed. What would be vertical speed? Wrong bloody component. Maybe jump falling. Just looking through the various options to see if there's one here that will work with what I want it to be. Max fly speed only changes. Won't do it because max fly speed. Unless let's try actually. Let's change it to. Let's double it. Obviously, that's going to change the horizontal movement, but we're going to lock that off anyway, so it doesn't really matter. See if if that's faster or not. Does it look faster? See, horizontal movement's a lot faster. Is that faster? Let's change something ridiculous and extreme. Let's see. Let's add another 0 in there. See if that really does anything. No. So the max fly speed has no bearing on the actual flight of the character. I'm going to guess it's something to do with the jump then. Jump velocity. So if I change that to say 1000. Again, it's hard to tell if that's fast or not. Let's turn off gravity while jumping. Does that do anything? No. So Kuro has just asked if the scale value of the added movement input would affect it. No, what this scale value does is basically changes the value of world direction. So if I made that -1, this would flip all this direction. So it's not going to do anything in that regard here. Let's see what force does. Nope. Oh, this is a pain in the butt. I'll change it anyway because everyone keeps saying that may do it, but I'm pretty sure it doesn't. If I change compile there. Yeah, no, see, it changes the this vector here. It doesn't really do anything. It's just a direction. It's not a velocity. It's this because you're adding movement input to it. So the movement you're adding is this sort of jump. But I can't imagine. Turn it back on. No. Jump. Flying. No. Hang on, hit up Google. Yeah, let's have a look. UE4. Flying. That's not coming back up with much. Okay, let's have a look at the movement components here. See what else we've got as an option. Apart from add movement input. Is there a fly one that does anything? Nope. Okay, well, I'll come back to that in a moment. We'll continue with the rest of it and come back to getting it climb faster later. Okay, so where we got up to was we got it so it drops down when we hit the ion. Maybe set the flying speed by vector. Just reading what everyone's commenting are. Has add impulse and set velocity. Try launching, but the problem with launching is it adds an impulse, which we don't want. We want a steady climb, and impulses don't give you that. An impulse is just like a sudden burst of energy at the start. We could use physics to climb it and just add a force to it. That's it. We'll come back to that in a moment. Let's lock off the sideways movement so we only climb up. So basically, we turn off W, A, S, and D whilst we're climbing. Well, especially A and D, we can turn off. So with character movement, we can constrain it to a plane. If I look here, you can see constrained to plane. So when I'm climbing, I'm going to get my character movement, and then from there, I'm going to constrain it to a plane. So I'm going to set constrained plane. Constrain. Which one is it? One if this no, not normal. Do this and we want to get the local the actor. Oh, no, we don't. We constrain it in the Z by 1 and the X by 1, turning off Y. Are these world coordinates? I don't know. No, they don't seem right. Which one is it? Constrain to constrain normal to constrain normal vector of unit length to the plane if enabled. Set okay. Uses the forward and up vectors to compute the plane that constrains movement. Enforced if the plane constraint is enabled. Not too sure. I've never turned on plane constraints from blueprints. I've always had to do it from the get-go. Constrain normal to plane. Nope. Constrain. Set normal with the plane that constrains movement. Enforce if the plane constraint is enabled. Change normal automatically sets. Oh right, okay. So I will constrain it in the 1 in the Z, 1 in the X, and let's just see if that does it. Nope. Oh. Mm, 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 mm. That's normal the plane that constrains movement. Enforce the plane constraint is enabled. Oh, I need to enable it. Oh, there we go. Set constrain. Oh, normal. And I want to constrain it in the Z. Let's see if that works. I'm not too sure which way it's meant to work, but let's see. Okay, so it's okay, so I see it's moved me. Okay. Let's change that to 0. Just make it go in the Z. No, not moving at all. So change the other ones to 1 and that one to 0. See if that's the correct way around you want it to go. Now it should only go up. Yeah. Oh no. Right. Well, I've got left and right turned off. So the problem is that these normals are world location, and I want it to be local to the character movement. So what I want to do is, if I get a forward vector of our rotation, so get the camera, get world rotation. So let's see if this works. Right, so it's now locked me to that, which is not what I want. Set constraint. No. Trying to work out what it's actually constraining there. So when I push up, I can move left and right. I can't move forward or back. So it's locked the. So okay, so it's locked the forward vector and nothing else. So what I want it to do is do the opposite. So I want it to clear this forward vector away from the rest of it. Oh, that's annoying. Okay. Well, let's get the right vector then and see what it does. Because I don't want it to be able to move right or left, which is good. I can move forwards and backwards. I can't move left or right, and I can move up and down. Okay, so that seems to be the one. Okay. Okay. So we've got the constraint going on here. So I've got the camera and it's a rotation, it's current world rotation, and I'm getting the right vector of it, and that's the direction to the right of the camera. And the way the normals work, because it is a constraint on a normal, it affects the whole entire plane, so it goes to the left and the right. So that's affecting that. Okay, so we've got that coming on here. So when we let go, we need to tell it to turn off. So we could just disable this. So if I get that and that, and I don't have to do the other bit because it's disabled if I turn it off. So when I land, I should be able to walk around like normal. So I can't move left or right. I can move forwards though. And as I've landed, I can now walk around freely. Nice. Okay. So we've got that. So now we want it to be able to work out how long we've been climbing for, and after a certain amount of time to drop you. So you can't climb infinitely. We want it to be able just to drop you after a certain amount of time. And then we'll work out how to do the speed. So this set timer by event is going off. Actually, I wonder if this will change the speed. If we change the time of this to something really small, because it's happening more often, would that mean it's going up higher? Oh. Hang on a ticket. There you go. That's it. That seemed quicker. Let's do that again. Let's go 0.001. So that's really quick. There we go. That's how we do it. We can just change how quickly it iterates for the climb. Nice. Okay, so we now want to tell it to what do we want to tell it to do? We want to to do a timer thing, so we can't just climb forever. So let's, for example, say I want to be able to climb this, but not this. Okay, I want to say we can't reach the top of that. So we need to do a timer on this bit as well. So climb wall, and what I'm going to say is make a custom event here. and I'm going to call it drop, and that's going to be tied into that same branch here, so it'll be exactly the same as releasing jump. So after amount of time, I want to call drop. So climb wall, the triggers. What we'll do is actually at the end here is we'll set a timer by event, and can I do that there? Event. Let me hear that. Oh no, there you go. So I can tell it to drop after, say, I don't know, let's say 3 seconds. No, let's do 2 seconds. So after 2 seconds, it'll call the drop event, which will basically stop jumping, or stop climbing in this case. Hit play. So 1, 2. Okay, so it works. It just needs to be a bit quicker, or make my climbing a lot slower. Here we go. There you go. Okay, so 1, 2. Still too fast. Okay. Let's change that to 1. 0.1. Okay, so there you go. It drops. So I can climb small things, but big things, it drops me. Cool. Okay. Not too bad. Okay, so we got the dropping part happening. What I want to do now is I want to make it so that my climbing speed changes over time as well. So at the start, if you play Apex, for example, your climb speed at the start is a lot faster than it is at the end, to indicate that you're tailing off and about to lose energy and about to fall. So this timer here needs to be a variable that we can change over time, which will be a timeline. So my variable here, I'm going to do climb speed, and this is going to be a variable type of a float. And I'll say, if I say my maximum speed is saying look like 0.1, we can do a range here. So if I slide a range here, a value range, I can go 0.1 is my maximum, and my fastest could be 0.001, for example. So now it will only go between those ones. And if I want to do a slider, I can do exactly the same values here. It kind of forces it to be between those values, like so. Compile. Nice. Okay. Let me just check the chat quickly. Make sure it's yep. Okay, chat's okay. Cool. Right. Okay, so yeah, so I've got this climb speed. We can do a timeline for this thing. So when we start the jump, I start the climb. Over here, we're going to do set timeline. Oh no, just add timeline, isn't it? Add timeline. And this is going to be climb speed. Oh, climbing speed. And the timeline here is going to open up and add a float track. Speed change. No, speed value, we call it. Speed value. And when we're going for 2 seconds, so from the first point, I want to be at 0 time, but the value of 0.01. And the 2 second mark, I want the time to be 2 and the value to be 0. 0 just 0 actually. Let's just see the graph like so. And we're going to make this not so linear, so I'll make this a bit curvy. So select it and right click, and you can change how it interpolates. So you can see it now get its nice curve. Compile that and change it to 2 seconds. And we can put in other values in here to make it hold that last value for a bit longer. So we can do this sort of effect, like so. So it'll get slower and slower and slower. Hold the slowest speed as long as possible before it drops down to 0 and drops you. So that'd be cool for us. We'll compile that and close that now. And when we play that, our speed value here, we're going to drag into climb speed and choose set climb speed into update, like so. Now I'm in my actual climb wall thing, I can drag climb speed into it, like so. The default value for this is going to be 0.1. And I'm going to also print string, just so I can test if it's working, my climb speed value. Okay, so one little fault is that the speed, well, for a couple of things. First of all, this needs to go to a play from start, and I forgot that actually the lower number means the faster it is, so I need to put this at a lower number and this value here at the higher number. So this one here would be 0.1, 0.1, like that, and then that will drop off at the very last second to 0. Let's see how that looks. So I go up to this wall, climb fast, and let's do that again, play. Let's make a bigger wall, let's make a really long wall. Really obvious. Oh, I need to. No, why is that not going back to the start? So when I push play from start, speed value should be back to what I set it out originally. So, which is here, 0.01. So it gets slower and slower till here. Let's change that to 0.5. And this one to 0.5. Make it really obvious at how slow it is. So it goes from 0.1 to 0.5. And it's set to 0. Why is it set to 0? And only being called once as well. I told it to go from start, so why is this not working? So the first time I do it, it's fine. This works just fine. The second time I do it, So what happens when I let go and we do this again? So I hit drop happens, it stops jumping, sets back to walking, which is fine because we reset back to flying up there. We're clearly invalidate time for climb timer, which is fine because we set a new one up here somewhere. Where is it? Oh, yeah, here. And then we set the constraint to false, which is correct. And up here, when we push jump again, we've got another timer going on here, but it's fine because this timer is just doing drop, and that just resets when we reset a new one. But when we do that, it's going to play from start of this. And let's just do a print string here of a hello. And disconnect this one so it doesn't get confusing. So that timeline's working just fine there. Working fine there, but the value doesn't seem to be where it should be. So what's going on there? I'm just going to do a tick here. To plug in this string here, we should look at the climb speed so I can see what the climb speed is like at all times. Let me just delete this. It's like it's being set to 0 and then stopping and not going back to it. So 0.5 back to 0. Why is it not climbing? It climbs a little bit by the looks of it, but it just stopped. It's not as good. What is going on there? How weird. So even though the climb speed is acting the same, the climb timer isn't. Hang on, this was only happening once, wasn't it, on the second go? So why is that only happening once? It should be on loop. First one's not a problem. First one climbs just fine. But the second one, yeah, so it only shows it once. That means that this loop here isn't looping. So our climb timer, it's been set again, so I don't understand why it's not working. The climb wall's being called again. Set timer, climb timer. Do. Maybe if I clear this timer and cancel it, if we drop prematurely or whatever. So if I change this return value here to promote variable and drop timer. Play from start. And when I drop, I'm going to clear and invalidate this one as well. Now let's see. So that climbs fine. That doesn't. Oh, that's infuriating. Hang on. Add brainwave. Hang on. Let's just test it works. Set climb speed. Back to 0.1. Nope. The brainwaves are false. Okay. If you have any ideas or suggestions that I can try out, throw me in the chat and see what we got going on here. But I am at a stump at the moment because that should work. For some reason, this has only been called once on the second go. I cannot imagine why. Still can't imagine why it's only been called once. It wasn't doing this without the timeline, was it? If I turn off the timeline. So as the inclusion of the timeline. Okay, so the timeline's the issue. When you're debugging things like this, if something's broken when you've been adding stuff, go back, remove the stuff you've added, and bit by bit, and see what bit was the issue. So now I know my timeline is the issue. Even though I'm doing play from start, it doesn't seem to be doing what I wanted to do. So play from start is here, and I'm setting the value to 0.01, and is there anything we can do with that, I wonder? Let's get the climbing speed timeline out and see what functions we have with this. Can't restart it. What does looping do on the set timer event? Looping here, it just tells it to call this event every 2 seconds, so it's go on loop. I don't want to tell it to drop every 2 seconds because that's a waste. I want to do it once. This one's looping because this is sorry, not that one. This one's looping because I want it to keep going up as I hold down the key. It's a loop. We can see if like that does. I don't think it'll do anything, but we can try it. Kim North has just suggested, so that's the first go, and then the second go. Hang on, Kim, have you just fixed it? Kind of. I don't know what's going on here. Yeah. Oh, it kind of works. It's weird. It's not consistent for whatever reason. Sometimes it works better than others. 0.5. Okay, so let's go. When we do this, let's just reset the climb speed back to its default. So set climb speed back to 0.1. Compile and push play. I want it to start at 0.1 every time, which looks like it's more correct now. No, it's not. God damn. See, that 0.5 is the error. It shouldn't be doing that. So why the hell is it doing that? Maybe I've got play from bloody start. This should play from the bloody start. Sam, can you do a stream on setting the generic team agent interface to put NPC and players in different teams? As far as I'm aware, that thing is still bugged in Unreal. I haven't checked on it lately, but it was bugged. So you have to do it all like manually with like tags and things like that. Use last keyframe, yeah. We'll try that. So climb in 0.5. Push jump again No, it's still, you see at 0.33. I think that what's happening, that timeline's always going. So behind the scenes, it's always triggering. So when I'm pushing jump again, it's just jumping into the middle wherever it is currently out on this thing. So the loop is actually not what I wanted to do. I wanted just to restart, which this is what should do here. Do you know, we'll also add animations later, something like hand grab, wall edge, IK and that stuff. Unlikely. Time wise, it takes way too much time for me to do that, and I don't have time to do it in this stream. But it's something quite simple to do. You just take it to play animations on loop. I made some quick animations before I got on the stream tonight to see if any luck, but we'll see how far we get. I'm gonna get the actual code bit done first. Play from start. Why play from start is not working? I don't know. Well, let's try it without the loop, but with the use last keyframe. So climbing 0.1 to 0.5. Climbing to 0 again. It's like that play from start refuses to work. Can I restart this anyway? So set playback position, new position 0. Let's do this. So when we end, force the playhead back to the start. 0.1 to 0.5. 0.5 there. No, you stupid, annoying thing. Let's go back, and I just want to turn my movement back to its original settings. So jump Z velocity, set it back to default, and where's the other one? Where was the other one? Flyer speed, wasn't it? Flying. I left it at 600. That's fine. Okay, so 0.01 to 5. 0.01 to 5. So when I hit the key again, so on the, hang on. Just trying to work out what it's doing behind the scenes. Those numbers seem so weird. Okay, so let's go. Right. Okay, so it looks as though it only breaks if I let go of the jump key during the climb and not letting it just drop and fall. So what's causing that to happen? So the drop is what's not calling it. So when it's finished here, I won't actually call the drop function. So let's do that. Compile. Climbing. There we go. Climbing. Correct. Climbing. That's correct twice in a row. 3 times in a row. Yeah, it's when I'm starting the timeline and I let go of the key before the timeline's finished. I think. It's hard to work out. It's hard to see. So I'm now going to test letting go of the key halfway up. Oh, it's so weird, hard to figure out. It's hard to determine where it's being affected. So when I let go of the key, stop jump. All this is happening. So released, stop jump. Clear and evaluate timer. Yep. 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 Let's get rid of that because and this starting value is 0.01. 0.01. Get that correct first. Let's try this again. Okay, so holding down the key the whole entire time. Alright, I've let go of the key. Push the key again. That works. Key again. Right, so that works fine. So when you hold down the key the whole entire time and let it drop naturally, that works. So now I'm going to force the drop by letting go of the key halfway up. Okay, so I've got the 0.26. That worked just fine there. So halfway up again. Halfway up. Halfway up. Yeah, it's not terrible. I mean, it kind of works. It's just every now and then it gets a bit funny. Okay. So clamber, 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 up. Clamber, clamber, clamber. Oh, shit. There you go. Okay, so we got it kind of working. We could try and do some animation stuff. What have I got here? I did make some very, very quickly. Clamber. Bring them in here. So I did this very basic climb, this gammy climb here. So what we can do here is determine whether or not we're climbing or not. Let's tidy this up actually, because there's quite a lot going on here and it's quite messy. So I'm going to determine that all of this and this should be a function. So with it all selected, right click and you can collapse to function. Oh, it failed. Why did it fail? Climb speed can be placed in the function graph. What's climb speed? Oh, timeline. Okay. So we do this stuff then. Collapse to function. And I'm just going to delete my old climb function. And with the new one, that was called climb. Like so. So take the climb, start the timeline for the value, and I'm going to do stop climbing function, and that is going to take this, and this. Cut that from there. Put that in here. Okay, and just put that on there like so. That keeps it nice and tidy. Okay, so we've got an animation here that I want to play whilst I'm climbing. So actually, we need to check a couple of things off before we go into animation stuff, if I have time for it. I don't want to be on it for too long, so another 15 minutes. I want to be able to, I noticed a bug, if I was to clamber up here, I want to be able to pull away. Oh yeah, so the issue was that if I were climbing, drop and continue climbing, I can sort of catch myself on the wall before. So when I'm jumping, I can only climb if the floor is, if there's a floor beneath me, if I'm on the ground. So what I'm going to do here is in my character, when we do the climb bit here, we only want to do this if we're not falling. So get character movement out here, get is falling, and we want that to be part of this condition over here. So let me just drag this down here, and I'm going to combine these into an AND. So that has to be true and that has to be true for this condition to become true. So now that will stop me from catching myself as I fall. Oh, it's not working now. Typical. Is falling. Oh, I don't want it to be is falling. I want it is falling is not true. Not. There we go. So now I can climb. I can't catch myself. There you go. Cool. So we've got a clamber. I can't move left or right until I'm up. And the way you mount upwards, there's two ways to do it. You could do it the way we're doing it right now, which is just basically force it up with movement. Or you could do a root motion animation, which I did make, but I don't think we're going to use it actually. To show you it here. Animations. So here I made a root motion animation for it clambering. If you were to enable the root motion on that and set to clamber up, then the character will go with it. But I don't think we actually need it in this case. So if we go down here, enable root motion. Like so. Why is that not turning around? There you go. Okay, so for example, if we want to determine whether or not we've climbed up a ledge, we'd have to do a capital trace above the player's head. I've got time. Oof, don't know. Let's have a look. So on the climb wall here, at the end of this, I'm going to do a check whether or not we've actually got a ledge to climb up on. So we could do a capsule trace, I guess. and the starting position for this, get actor position location. We want to make this above and in front of the player character. Christone 1989. What if you just made a class for climbable objects like ladders or short walls? A simple overlap trigger could enter the player into this climbing mode. Yeah, it could do. Yep, totally could. Totally fine. What we got here is it working with anything, like you see in like Apex and Halo and all that stuff. But yeah, you could do ladders like this. Totally fine. Get actor location. So for ledges, we need to determine the ledge. So I want to look in front of the player and above them. So I'm going to get their location and I want to add a vector to it. So in front of the player is X. So I'm going to do 150 in front of the player and then 150 above the player. And that'll be the starting position. And I also want to get the end position. I think that'll work. We'll have a look. For one frame, we'll do this. So as it's climbing, we should see this capsule appear. I'll make it the same height and radius as the capsule component of the player character. So the half height is 96 and radius is 55. So radius 55, half height 96. Compile that. We should see a little capsule appear in front of the player. I don't think you actually see it because it's obviously in front of us. Not useful. I don't want that. To get out to location. X. Okay, let's do a print string here. Turn value, compile. Right. Because when I see that, you see I keep on climbing up. So I want to be able to determine whether there's a ledge and tell it to stop climbing, just to move forward and clamber up. Where is this capsule? God, doing that. It appeared for a split second. Let's have a look. Let's change it to duration. That way we can see it all the time. So duration. And then see where it's spawning it. Okay, so it's slightly off the player. Oh, that one worked. It should be going from my local position, so why is it not? Okay, so it's always, okay, it's using the world coordinates. So I want to transform location. 50 in the X and 150 in the Z. Let's see if that does it. This is not world location, is it? No. No, same problem. Oh. Local location. No. Location. Get the use forward vector. Yeah, I guess I could. Yeah, use the forward vector. Oh, just plugged my cable. Get rotation. Oh, get the actor rotation. Get the forward vector. Yeah. Times it by value. We'll do 150 because we know that works. And add that to this. And I want to raise this up as well, so I'm going to add another pin to this and raise it by 150 up in the air and plug that to start and end. That's better. Okay, so it's doing the capsules, but they are not doing what I wanted to do. They should be hitting it changes the camera. I should be getting some trues, not just all forces. So why are we getting forces? Crystone, climbing animation with root motion allows the character to step out of the capsule radius. Actually, root motion is the opposite. It moves the capsule with the animation. So it's the other thing it does. Yeah. Why is that not coming back as true when it is hitting it? Oh, I don't know. That should be like when it's climbing up the wall, it should be true, 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 and then false. But it's false all the way up, which makes not much sense. Oh wait, it's because yeah, yeah. I'm being dumb. It's late. Pardon me. Do that. There we go. So when we hit the true and false, like so, I'm gonna make this a bit smaller, half height. I'll make that half of that 96. So it's what 48. Compile. Ideal goal is that we get a red bit as soon as we hit a ledge, or near enough. Okay, so we've got one red bit there. So what I want then is when this is false, that's when we have a the ledge. Okay, so with that ledge there, we can then, well, we could do a few things. We've got root motion, like I've got on my arms clamber here. So if you want to see what root motion looks like, you can go into where is it? Character, animation, process root motion. You can see it over and over and over again. What happens when it loops? So if I go into and make this montage, create and then montage, that'll do. And we're going to tell it to play that montage. So when it's false, play montage. And Clamber. Let's see if this works. We may have to change something on the animation blueprint. Yeah. So on the animation blueprint, we usually have to turn on root motion from everything, just to make sure. Let's see if this works now. Nope. Is this working in the montage? Yeah, it's working. What if I just tell it just to play just the montage? Oh. Not montage, animation. Play animation. Clamber, delete that one. God damn. Right, so why is that not it? The montage should take over everything, so the montage should be the one we want to use. Not that one. Play montage. Let's do it this one. Clamber, and the skeletal mesh is this one here. And push play. Oh, it kind of played it and then broke the climbing. Yeah, I'll go back to it. Oh, we could, yeah, I think we're gonna have to go into a proper like animation blueprint to do this, but we don't have time for that for tonight. But that's how you detect ledges. You can do stuff like that. Yeah, you could do a capsule, or you could do lines. I prefer capsules because that way you make sure the ledge is actually a ledge and not just a hole in the wall. Well, you guys get the general gist. Okay, I think we're going to have to start wrapping up, guys, because it is getting quite late for me. I do have to get some bed. So thank you for coming by and watching. If you've just joined us, we have been making the Clamber system often seen in FPS games. Let me just turn off the debug on this so I can show you what we've got with it. So think of like games like Apex Legends and Halo 5 and other FPS games that include it. Clamber systems are where you can run up against any wall, hold down jump, and climb up it like so. And you can't climb infinitely, so we made it so we can climb up and it will drop us after a couple of seconds. And also the rate you climb changes based on time as well. So you when you start the climb, you're faster, and when you reach the top, you're slower. There are a few things that we didn't get a chance to do, such as the animation stuff. And also another thing we want to try and get done is being able to jump into it. So if we jump into it like so, into a climb and climbing up, we don't have that in there, but we can do so forth. Okay, but that's something for you guys to play about if you want to play with it. If you've missed most of the stream, don't worry, it will be available on video on demand immediately after I hit this for all my patrons via patreon.com/Ryan Laley. Just donate $1 and you can access this video on demand straight away. Otherwise, wait 2 weeks and it'll be available on the YouTube channel for free for everyone else. Next week we'll be doing another live stream, but next week's one is back on rotation to the question time. So if you don't know how live streams work, we have 4 topics on rotation. We have the Unreal 4 tutorial series, which you saw tonight. Next week is question time. The week after that is our game that we're developing live, and then after that is a case study playing a game and talking about the design decisions behind it. And we do that on rotation every Saturday at midnight. So thanks again for everyone coming by and watching, and don't forget to subscribe to the channel and enjoy the rest of the content. The Advanced Dialogue series is now complete and available for everyone on the YouTube channel. Next week we'll be starting to show off the Shooter AI series that has been happening for the patrons. The patrons have about 7 or 8 episodes right now, more on the way, and we have another few episodes coming out of other odd stuff coming out this week and week after next as well. So loads of stuff coming out, lots of cool stuff. Don't forget to also check out the new website. The website's been updated as well. Just go to ryanlaley.com and you can see the new website, new blogs and so forth about what we're doing. And thank you for everyone for supporting the channel thus far. We are growing, we're getting bigger, stronger, faster, all the rest of it, and hopefully we'll be taking over the world very shortly. So thank you again everyone, have a good night, and I'll see you all next time. Bye bye.